having a very wonderful series on polynomials, and in the last video in the series I defined polynomial and gave examples of monomials, quadratic expressions, equations, linear equation, and so on and so forth. But we want to continue this with the algebra of polynomials. In the last video we discussed the addition or subtraction of polynomial. I said simply identify the like terms and add, subtract the like terms, and that is just basically or gives you another polynomial. So the sum of two polynomials gives you another polynomial. We are going to look at the multiplication of polynomials. Unlike the addition, the multiplication of polynomial, we have to apply the laws of indices. You remember our first video? We'll talk about the laws of indices, where we multiply powers. We add powers of similar bases. We add powers of similar bases. So you can always check out that video to understand what I want to do better. So we want to multiply. So let's say we have a polynomial 3x minus 2. This is a polynomial, obviously. And we have another polynomial, and that is let's say 4x squared plus 5x plus 1. So these are two polynomials. Let's see if we can. We know we can add this. So with your side, you can add this to our 4x squared plus 8x minus 1. That will be the sum of these two polynomials. But we want to talk about the multiplication. So the multiplication, we can have it as PQ. PQ is going to be a function of x. It will be a function of x. So what do we have? We have 3x minus 1, and we have 4x squared plus 5x plus 1. So how do we tackle that? So we start with 3x. We start with the first member of this polynomial, and that's 3x. So we use it to multiply everything here, which is 4x squared plus 5x plus 1. So this is my x. So we are done with the first member. We use it to multiply. And then the second member, which is minus 1, we use it to multiply all this again. 5x plus 1. So that's how we do it. That's how we do it. Very simple, so we don't have errors. So the interesting thing is that by the time we finish with this, it's going to lead us to addition of polynomial. So interesting. So this we are going to be having, we are going to multiply this by this. Please take note. Coefficient with coefficient, and for the basis here, x is raised to the power of 1, x here is raised to the power of 2. So we add the powers. Please, you can always refer to my first video. I took my time to explain that. So 3 times 4 is going to be 12. Then here is power 1 and this power 2. So this is going to be x raised to the power of 1 plus 2, and that is 3. This and this now give us 3 times 5, which is 15. We add the powers again. This is power of 1, the power of 1. So this is going to be x squared. Finally, 3x times 1 is going to give us 3x. So that's how we add. So for this is quite simple. This is more like a scalar multiplication. Minus 1 times is going to give us minus 4x squared. Minus 1 times is going to give us minus 5x. Minus 1 times is going to give us minus 1. So we fall back again to addition of polynomials again. So, and that is going to be happening with like terms. So we see like terms here, we see like terms here. So we just do that. And that will give us 12x cubed plus. So 15x squared now minus 4x squared. So these are like terms. So 15x squared minus 4x squared. 15 minus 4 is 11x squared. And this is going to give us 3 minus 5 is minus 2. So that's going to be minus 2x. And this is lonely here, no friend. So minus 1. And that is the answer. I can't go further than this because these are different terms. This is 12x cubed plus 11x squared minus 2x minus 1. And you know what kind of polynomial is this? This is a cubic polynomial. It's a cubic polynomial. So you can try this on your own. You can try this f of x equals to 9x squared plus 1. G of x equals to, g of x will be equals to 5x squared plus x minus 2. So do f times g of x. So multiply these two, f times g of x, and try to get your answer. That is that. Now, you can see the interesting thing. We are discussing multiplication of polynomials, and it's leading us to addition of polynomials. Now, there is another algebra of polynomial that will lead us to everything, and that is division of polynomials. We can also divide polynomials. And when we divide polynomials, it will lead us to multiplication, then lead us to addition of polynomials. But I will have to take my time to explain the steps that are necessary in polynomial division of polynomials. The steps that are involved, very interesting step, but when we divide polynomials, let's say we have p of x, the polynomial, and we have another polynomial, let us call it d of x. And we have p of x divided by d of x. This is what we want to do. We want to divide it by this place. But take note that this should not be 0, please. That would be crazy to divide by 0. So when we divide polynomial, it is going to give us an answer, and that answer is what we call the dividend. So we'll call it the dividend. I don't know. I think I would rather write this as okay. Let me write this as f of x. It's okay. Then we are going to have a remainder. And this. Sometimes you're sad when I bring out things like this, but I'm going to explain that in a term we all understand. Now, remember if I tell you divide 5 divided by 3, you remember this? Let's say 5 divided by 3. You know, this is going to give us 2 whole numbers. We have a remainder and I'm sorry, this is one whole number. Sorry for that. One whole number, 5 divided by 3 is one whole number. Then we have remainder 2 over the same divisor. We call this divisor. Take divisor. So this is divisor, this is called the dividend. Divided. So dividend, this is called the quotient. And this is called the remainder. So the same thing happens here. It's just the same thing because this is written as 1 plus 2 over 3. This is just the same thing. So we divide it by this. You have the divisor. You have the dividend. What you want to divide is called the dividend. So 5 divided by 3 gives you one whole number. You have the remainder. Divided by what you use in dividing, which is the divisor, which is d of x, which is this. So what you're saying here is just the same thing you have been doing in your grade 3. So I'll plead that you put a smile on your face. It's just the same thing you have been doing all over again. And it's just that we're going to be using different steps and different techniques here. So the intro or the outro for this video is going to be the intro for the next video. The steps that we use in dividing is the first step, the second step, the third step. I'm going to outline the step. We're going to solve a problem, and I'm going to give you opportunity to solve as many problems as possible. And division of polynomials sometimes is always very tactical. We have other method like the synthetic method. I'm going to show you the first method, that's to do with the long division method. The long division method is still similar to the division method we did and in our earlier grades, in our early grades. So we're going to be applying them with some principle and we'll get our answer. So next video, division of polynomials. Thank you.